All right. Chapter 4 tests will come in two parts, a non-graphing calculator part and a graphing calculator part. Monday we will take the non-graphing calculator part, and then Tuesday we will take the graphing calculator part. Now Monday's part, you will get Monday and Monday only to work on that one. Tuesday's section, you will get Tuesday and Wednesday. And there will be a stipulation on Tuesday that whatever problems you start, you have to finish on Tuesday, and then you get Wednesday, which is a shortened day, to finish the rest of it. So, with that, this first video will only cover Monday's portion of the test. There will be the other one online for Tuesday's part. And you can watch that sometime this weekend or possibly even Monday night. Your choice. This one will also be online the whole time, so you can rewatch it over the weekend if you missed something or want to review it again. So the things that you will cover on the test on Monday will be naming the angle that a quadrant lies in, finding the complement and supplement of angles, converting angles from degrees to radians or radians to degrees, finding exact values. That would be like your big circle thing. Then finding the length of an arc, the area of a sector, and determining the period, amplitude, and shifts of a graph. That fine pink sheet that you have that you've been using to do all those things, you do not get to use it on the test. You need to know all of those things. All right then. Looking at some examples of all the different things. These letters here on the side represent the problems that we're going to be doing as we go through this review. So first thing, naming the angle that the quadrant lies in. It is 3 pi over 5. So if you have a coordinate plane, remember that this number here tells you how many times the from here to there it is divided up into. So this would be 5 equal parts, and there would be 1 there, 3, 4, and 5. Oh, that's too many. That's 6, so that would be a big mistake. Let's try that again. Okay, so we'd have 1, 2, 3, 4, and 5 equal parts. So 3 pi over 5 would be here, and that puts you in quadrant 2. Now, if you're bad at drawing, then use your math skills and know that this right here is the halfway point, and 3/5 is bigger than 1/2. So therefore, it's got to be just past the halfway point of the top half, and that puts you still in quadrant 2. All right, moving on to the next one, a negative 46 pi over 7. So that would mean we would have to go this way around the circle since it is a negative angle. And this has to be divided up into 7 equal parts. So there's 7 pi over 7. There's 14 pi over 7. There's 21 pi over 7. There's 28 pi over 7. There's 35 pi over 7. There's 42 pi over 7. And then there's 49 pi over 7. So 46 pi over 7 is somewhere in between those two. This one right here, this would be 45.5 because that's halfway in between 42 and 49. So 46 has to be in there. That makes this quadrant number 3. Now, if you do not recall your quadrants, remember this is 1, that is 2, that is 3, and that is 4. All right. Moving on then, finding the complement of an angle. For 4 pi over 7, to find the complement, remember they have to add up to 90 degrees or pi over 2. So since we have 4 pi over 7, you would take pi over 2 minus 4 pi over 7. In order to subtract, you would need a common denominator, which in this case is 14. This one has to be multiplied by 7 to get to 14, so this is going to be 7 pi over 14. This one would have to be multiplied by 2 to get there, and that would be minus 8 pi over 14. And 7 pi minus 8 pi is a negative pi over 14, but you cannot have a negative angle that's a complement. So therefore, this one is not possible. Now, if you recognize that ahead of time, you could have just said, oh, that 4 pi over 7 is bigger than a 90-degree angle, so therefore it's not possible. Or you just go through the whole subtraction process and you get the negative angle, then it's not possible. Not saying that you'll get one that is not possible. You might get one that is. That is how you do it. It's just subtracting a couple of simple fractions is all that have pi next to them. All right, then moving on to the supplement. Same thing. Take pi minus 4 pi over 7. And again, you need a common denominator, which in this case can be 7 or 7 pi over 7. And 7 pi minus 4 pi is 3 pi over 7. Moving on then, taking 430 degrees and converting it to radians. Well, you have to multiply by pi over 180. The pi is going to stay there. You can take a 0 away from both of those two things. And then you're left with 43 pi over 18. All right then, moving on to 7 pi over 5, changing it to degrees. This time you have to multiply by 180 over pi. And the pi's can divide out. And I do believe that 5 goes into 180 36 times. And so then we have 7 times 36, which is 252 degrees. Our next problem that we are going to look at is given the coordinate negative 5, 12, find the 6 trigonometric functions' exact values for them for that coordinate. Well, if we plot the point negative 5, 12 is right here, which puts us in quadrant 2. And before we even start anything, we know that cosine is negative, sine is positive, and tangent is negative, which then also means secant is negative, cosecant is positive, and cotangent is negative. And so we would then make a right triangle like so. And this is the angle we're dealing with, which is also the same as that angle as far as things are concerned. But we only have to worry about the right triangle. And so here, like I said, is our angle. This would be 12. That would be 5. And then you would use the Pythagorean theorem of 5 squared plus 12 squared equals the hypotenuse squared. And that, in this case, becomes 13. Or you just remember that it's a 5, 12, 13 triangle from your days in geometry. And so now cosine of theta is going to be a negative 5 over 13, which then turns secant of theta into a negative 13 over 5. Sine of theta is going to be a positive 12 over 13, and then that makes cosecant 13 over 12. And finally, tangent of theta is going to be a negative 12 fifths, and cotangent of theta is a negative 5 twelfths. Of course, I'm thinking that the problem won't just be some sweet number like 13 for the hypotenuse. It'll probably be something like the square root of 73 or something along that line. And then you got to make sure that when you do any of these things, that if it is the square root of 73, you can't leave it like this pile. You would have to take it and make it negative 5 times the square root of 73 over 73, because you aren't supposed to leave a square root in the denominator of a fraction. Moving on to the next thing. Given an angle of 70 degrees, and there's a radius of 12 in a circle. So we have a circle that is 12. We are dealing with an angle that is 70 degrees, which is like right there. Find the length of the arc. Well, if you recall that the length of the arc is equal to theta times the radius. And theta would be 70 pi over 180. And then you can take that and put it and get rid of that. And then you would get times 12. So that becomes, we can take an 18 out. Or we can divide 18 and 12, I should say, by 6. Make that a 2. Make that a 3. Excuse me. And it becomes 14 pi over 3. To find the area, you would want to take 1/2 times theta times r squared. And then that would be 1/2 times 7 pi over 18 times 12 squared. And you would get 28 pi for your answer. And that would be in square units. And this would be in just straight up units. Then another one could be, okay, if you have find the central angle, if the arc is 72, so we still have a circle with a radius of 12, and now we know that the length of it, that is 72, which is quite a ways away around the circle, I'm guessing. And remember that theta equals arc length divided by the radius. And that in turn turns into 6 radians. And then if it asked you to convert it to degrees, you would have to multiply that by 180 and divide by pi. And I do believe you will get 343 degrees. Then finally, you will be asked to name the different parts of the graphs of these particular functions. In this case, the amplitude would be 5. Now, if you said a -5, I would let it slide because, yes, that negative does affect the graph in that it starts at its minimum and then works its way back up and down. The period would be 2 pi times the reciprocal of what's being multiplied with the x, which is 2/3, so 3/2. That turns into 3 pi for a period. The shifts, then, right and left, would be this part, so it's left pi over 4, and then the up and down shift would be down 7, because that's what it is at the end, so it's -7. Now then, looking at this next one, 2 sine 7x plus pi over 4 minus 3. Amplitude, 2. That number there. Period, again, it's 2 pi times what is ever with the x, which is 7 in this case, and the reciprocal of that is 1/7. So 2 pi over 7 is the period. So this one is really tight as far as its waves are concerned, because the period is 2 pi over 7, which is not very far. Then the shifts, right or left, would be left. But we're not going to call it pi over 4 because you cannot figure out the right and left shift until the x is by itself, which means you've got to divide this by 7 and also divide that by 7, which is the same as multiplying by 1/7. And 1/7 times pi over 4 is pi over 28. And then finally, the up and down shift would be down 3. And then finally, this last one here, -3 cotangent 1/3 x plus pi over 3 minus 2. It has a stretch vertically of 3. Period. Remember, with tangent and cotangent, it is pi times the reciprocal of what's there. So that would be 3. So 3 pi. Right or left shift would be left. And because the x is already by itself, we don't have to worry about dividing out anything, so it's just left pi over 3. Up and down, this time would be down 2. And that will conclude your part on Monday. Like I said, the Tuesday part with the calculator, that review will be online for you over the weekend, and you can look at that starting tonight if you wanted to, or you can wait until later on in the weekend or even on Monday to get yourself ready for Tuesday's part. Have a nice weekend. And you can use the rest of the time today to maybe pull out your book, go through some of the problems in the review assignment. That might help you get ready for it on Monday.